Just for Mira. Hello guys and welcome to Okay. ठीक है वापस आ जाते हैं. Right, let's come back. Okay. We are discussing equilibrium. Okay. Very important topic. And a very difficult topic, so to say. है ना? A lot of times. मैंने इसकी वर्कशीट बनाई. कुछ 60 pages जितना इसका वर्कशीट है, right? But there are only 4 types of questions which can be asked. To understand all these 4 type of questions, first let us understand the whole topic. ठीक है? We will start with a very simple observation that we can take, right? Let's say कि I have taken a bottle of water, okay? I fill it half with water, ठीक है? और मैं इसको ऐसे छोड़ देता हूँ, let's say in a room, but the cap of the bottle is closed. What will happen? Let's say after 5-10 days, what will I observe in this bottle?
The water will evaporate.
Water should evaporate, but because I have closed the cap, water will not be able to escape.
Yes.
But what you will see tiny droplets of water.
Yeah, so
Foggy
kind of, yeah.
Not foggy, but there will be droplets of water on the surface. Does everyone agree?
Yeah.
ऐसा होता है ना? कभी कोई बॉटल भूल गए हो थोड़े दिन तक तो you will observe that this is happening.
It has some kind of white layer on it.
White layer जैसा हो जाता है, ऐसा कुछ हो जाता है ना? What is happening? Can I say that evaporation is taking place at the starting? When I just keep it, right? What will happen? Evaporation will keep on taking place. Evaporation is in this direction. But because the bottle is closed, what will happen? Slowly, the air becomes saturated with water.
Yes.
Now it cannot contain any more water at this temperature. And as I have kept it in a room, ideally room temperature is somewhat constant. है ना? 20-25 जितना होगा. But whatever it is, for 1 or 2 days, it will remain fairly constant. ऐसे 1-2 degree difference आएगा inside the room, which is okay for our experiment right now. So what will also start happening once that saturation point is reached, right? For any more water to evaporate, some water has to condense also.
Yes.
है ना? So after some time, what has happened? The rate of evaporation is equal to the rate of
Condensation.
So let's say I started with this level of water. After 1 day, probably this will be the level of water. But once that equal rate of change has been reached, the water level does not fall anymore. The number of particles evaporating is equal to the number of particles condensing. Does this make sense? है ना? Everybody? Okay. देख अमन बैठ जाओ बेटे. क्या समझाया मैंने कि ये एक बॉटल है, right? इसका कैप closed है. Now, if I have filled water in this and I left it in a room, the water will start evaporating.
Yeah.
This evaporated water will saturate the air above it, and then there will be a point where if any more water wants to evaporate, some water from the air needs to condensate. Right? There will be a point where this equation is reached. Does everyone agree?
Yes.
Please write this. और क्या करें? लिख लो चलो, ये लिख लो. Then what we can do is, because I will post this video by today only, you can again go through this video and write the notes. But because Aman is just here, थोड़ा सा उसको settle होने का time ले लेते हैं. And all of you please note this down. Now what has basically happened over here is that the rate of evaporation is equal to rate of condensation. So in the simplest language, an equilibrium has been reached, where both of them are taking place simultaneously with equal rate, right? This is equilibrium, right? So just write down, and this is a dynamic equilibrium because changes are taking place, but the overall change is zero, है ना? So please write down the definition of equilibrium. There are two conditions to equilibrium, right? Equilibrium.
तो ये क्लोज सिस्टम है ना?
हाँ. So equilibrium is said to be established. Equilibrium is said to be established when
Is set or said?
said, S-A-I-D, said, said to be established when the rate of forward reaction, equilibrium is said to be established when the rate of forward reaction is equal to the rate of reverse reaction.
Is equal.
To the rate of reverse reaction. We have discussed physical change, ठीक है? Chemical reaction we have not discussed yet. करेंगे अभी?
Is equal to the rate of reverse reaction.
Such that, तो ये first condition हो गई, that the rate of forward reaction should be equal to the rate of,
Reverse reaction.
ये एक condition हो गई. दूसरा condition ये है, such that, continue the sentence, such that the concentration of constituents
Of
constituents
such that
the concentration of constituents
is present
constituents
CON
constituent remains constant. The concentration of constituents remains constant. Does this definition make sense to you? है ना?
Yes.
जितना water level reach हो गया वो change नहीं होगा. So its concentration is now constant
Yeah.
because the air above this is also saturated. It cannot hold any more water at this temperature. तो वहाँ पे भी concentration constant हो गया.
Yes.
यहाँ तक सबको पता चला?
Yes, sir.
Now, equilibrium behaves. Equilibrium. Before we understand equilibrium, हमको अवान ने याद करवाया एक important चीज that we need to understand systems, है ना? To look at it, देखो ऐसे देखो कि let's say ये हमारा bottle था. एक bottle है जिसका cap open है, एक bottle है जिसका cap closed है ना? And then we have thermos flask जिसमें हम पानी भर के लेके जाते हैं, right? Now, in this what happens if this was our point of experiment? तो क्या होता? That water could escape, equilibrium could not be established, है ना? Here, so what is this? This is an open system by the way, where energy can also come in and go out, particles or mass can also transfer. So if I talk about mass and energy, mass can transfer in an open system, energy can also transfer in an, but if you look at a closed system, why is this a closed system? Because although energy can transfer, mass cannot. I have closed the system. Any mass, any particles can neither escape nor get added to our point of interest, है ना? System मतलब the contents inside the bottle. We are interested in what is happening inside this bottle, right? So this becomes our system. What is a isolated system? Isolated system is like a thermos flask.
Vacuum.
Vacuum flask is a better word for this. Vacuum flask. What happens in vacuum flask? Neither the energy nor mass can flow in and out. Which is how we have understood this in physics. That this is how a vacuum flask is able to keep a hot liquid hot and a cold liquid cold for extended period of time. Because it does not allow energy or mass to transfer. Correct? Is this understood? Right? Now I want all of you to focus on learning this, because this video is being made. All of you can again go through the video and write notes, है ना? अभी फोकस क्या करना है कि समझ में आ रहा है या नहीं, एंड डाउट्स पूछना, राइट? वीडियो देखोगे तो एक और बार रिवीजन भी होगा, एंड दिस इज अ बिगर टॉपिक, यू विल रिक्वायर रिवीजन. ठीक है? So everybody please focus on learning today. Okay. So once we are through with that, right? Equilibrium is like a seesaw, right? किसने seesaw experience नहीं किया है लाइफ में? सबने किया है, I believe, है ना? Let's say यहाँ पे मीरान बैठा है ना? और यहाँ पे मैं, अपन दोनों के पास हाथ है मीरान है ना? यहाँ पे मैं नहीं, मीरान और ध्रुव है, ज्यादा हो जाएगा. Let's say that they are sitting at a certain distance. We know clockwise movement is equal to handle all of that, but they are sitting in such a way that the seesaw is balanced, है ना? Now, if something disturbs this seesaw, ये already एक बार balance हो चुका है ना? If I go and press it on this side, ideally what will happen? This side will go
down.
है ना? But as soon as I remove my hand, what will happen?
It will again
Up.
it will go up.
Yes.
So, if I compare this seesaw with equilibrium, can I say that the equilibrium will oppose your change?
Yeah.
I am trying to push, let's say ये ध्रुव है भाई और ये मीरान है ना? Correct spelling है?
Yeah.
Okay. So if I push ध्रुव down, right, what will happen? मीरान का side ऊपर हो जाएगा, but as soon as वो remove होगा, equilibrium फिर से establish हो जाएगा. So can I write it like this, that equilibrium always opposes your change? Make sense? In this example, भाई बोल रहा हूँ कि बाद में लिख लेना, अभी सुन, मैं नहीं रुकूंगा, मेरा ना सुन, ज्यादा एनर्जी सुनने में लगा. Okay? Do you agree with at least this seesaw example?
Yes, sir.
If you try to change something, the equilibrium will act in such a way that it will try to re-establish the equilibrium. है ना? Now, let us have a look at a chemical equation. ठीक है? So there is one such equation where hydrogen iodide, if you heat hydrogen iodide, it decomposes to hydrogen and iodine gas. Now to balance the equation, I will write 2 over here. है ना? Is this understandable? Because I am heating it, only this decomposes then. So this is an endothermic reaction and this is a, if it has to be a reverse reaction, it has to be an exothermic reaction. Only then I will call it a reversible reaction. है ना? यहाँ तक everybody with me?
Yes.
Okay. Now the question is, if I start with hydrogen iodide, right? Let's say मैंने एक chamber में hydrogen iodide ली, right? And then I start heating. Let's say for our example, it starts decomposing at 150 degrees Celsius. So I am maintaining 150 degrees Celsius in this chamber. it will start decomposing to hydrogen and
iodine.
iodine. Starting में क्या होगा? Very rapidly hydrogen and iodine will be made, right? कब तक hydrogen and iodine will keep on? कब तक बनता रहेगा ये?
Unless the
So it is made very fast until equilibrium point is reached. After that, will it still be made?
no.
It will be made, but then some will always convert back.
Yes. So hydrogen iodide, even after reaching equilibrium, still decomposes to hydrogen and iodine. But now, because there is an equilibrium, at the same rate, hydrogen and iodine combine to make hydrogen iodide. Never forget this. Otherwise, it was not an equilibrium if reverse reaction was not taking place. So, even after it reaches equilibrium, there is a forward reaction, but the rate of forward reaction and the rate of reverse reaction are same. So, once let's say I have 500 grams of hydrogen and 500 grams of iodine, in that particular equilibrium, for an example, it will stay that amount. The second condition, the concentration of constituent remains constant, remains same, है ना? यहाँ तक सब समझ में आ रहा है सबको? पक्का? Okay. Now, what will happen? Keeping equilibrium का logic, that equilibrium always opposes your change. Equilibrium का logic समझ के, what will happen if I add more hydrogen iodide? Let's say I started with 1 kg hydrogen iodide, है ना? And ये दोनों 500 ग्राम बन सकता है if the reaction goes to completion, right? But क्या होगा? Somewhere थोड़ा सा ये बाकी होगा because there is an equilibrium. So some of this is left, some of that forms and some of this forms, and then there is an equilibrium. Although the reactions are taking place, the quantity remains constant. What will happen if I suddenly increase hydrogen iodide? Now compare it with the seesaw, है ना? यहाँ पर एक fulcrum है. If I add hydrogen iodide, what am I doing? I am lifting this up, है ना? I am increasing the concentration or the quantity of hydrogen iodide. What should the equilibrium do to oppose me?
So the hydrogen and iodide
Will decrease.
concentration will decrease.
Will decrease.
What will decrease?
The hydrogen and iodide
Constant.
If this is being lifted up ऐसे
Yeah.
to re-establish the equilibrium, what should the system do? There are two
You
ways.
can
या तो
either
इसको
reduce
ये साइड को नीचे कर दे,
या तो
या
ऊपर।
तो इसको ऊपर कैसे करेगा?
Increase
Increase the number of hydrogen.
Increase the production of hydrogen and iodine,
Yeah.
which means unless a new equilibrium is established, the rate of forward reaction increases, है ना?
Yeah.
But when it does this, the hydrogen iodide concentration also,
Decreases.
so it is acting in the logical way we think it should. I increased the concentration of reactants, the equilibrium shifts towards right, such that the concentration of product starts
Increasing.
or the concentration of reactant starts.
Decreasing.
Both of these statements are correct. Okay, what is the statement? If you increase the concentration of reactants, the concentration of products will increase. The equilibrium shifts towards
Right.
okay. So right and left is a very important terminology in equilibrium. The equilibrium shifts towards right and equilibrium shifts towards left is a very important, right? Now instead of increasing hydrogen iodide, what will happen if I increase only hydrogen? Case 1, I increased hydrogen iodide, है ना?
Yeah.
Now in case 2, I am increasing only hydrogen. And remember, when there is an equilibrium, there is hydrogen, there is iodine, and there is also hydrogen iodide. तीनों present है in the equilibrium mixture, है ना? So if I increase hydrogen, what will happen? What will the seesaw do? पहले तो हाइड्रोजन इंक्रीज किया है, तो I have increased the side of the products.
Yeah.
So what should the equilibrium do logically?
Increase
Yeah.
reactance.
But that won't be possible, right?
Why?
Because iodine is not being increased.
Even if the iodine is not being increased, as it is an equilibrium, there is some iodine present.
Oh, okay.
That iodine can be used up to shift the equilibrium. अवान ने जो पूछा सबको समझ आया? अवान ने क्या बोला? And it is, this is where everyone can get confused. So pay good attention कि iodine वो तो increase नहीं किया है, तो only hydrogen increase पे कैसे reaction will go to the left side? Why will the equilibrium shift? Because in equilibrium we do have some iodine present. है ना? That iodine will get utilized. The rate of reverse reaction will increase and the equilibrium will shift towards reactant side. That is correct. है ना? So the second statement is, if you increase the concentration or the quantity of products, the reaction equilibrium shifts towards the है ना? And the concentration of reactants increase. Make sense? यहाँ तक एकदम परफेक्ट है ना? अब एक एग्जाम्पल, आई विल यूज द सेम इक्वेशन, ठीक है? एंड थोड़ा सा अगर इनडायरेक्ट पूछे, राइट? व्हाट इज द कलर ऑफ आयोडीन? डार्क कलर होता है, ब्लू, ब्लैक, ग्रे, ब्राउन, है ना? बहुत सारे कलर्स हैं, बट डार्क कलर होता है. हाइड्रोजन इज अ
Colorless.
एंड हाइड्रोजन आयोडाइड भी कलरलेस होता है. ओके? हाइड्रोजन आयोडाइड आल्सो कलरलेस, हाइड्रोजन आल्सो कलरलेस, है ना? नाउ दे विल नॉट आस्क डायरेक्टली दैट what will happen. They will say that this reaction has reached an equilibrium. After it reaches equilibrium, you have added. Okay, so sorry about that. Sorry about the little break. ठीक है. So this is endothermic. The forward reaction is endothermic. The reverse reaction is exothermic. And no matter what type of reaction it is, if I increase the temperature, the rate of reaction must increase, right? But there is some problem. Let's say that a reaction is instead of reaction, let's think about cooling of a metal cube. Let's say this metal cube is at 300 degrees Celsius, right? And I've kept it in a room of 299 degrees Celsius, right? Or 280 degrees Celsius, and that cube is cooling, right? I've taken a 300 degrees Celsius cube of the same size, same material, everything same. Just I've placed it in a room which is at 100 degrees Celsius. Which cube will come faster to 280, let's say?
The first one. Because it
100
starts out at a higher temperature.
Both of them are starting at 300.
Oh.
One room is at 280, the other room is at 100.
The one at 100.
Because it has the space to release its energy.
More energy.
है ना? The same thing would happen here. Let's say कि forward reaction का rate is 2 units, okay?
Yes.
And the backward reaction का rate is 2 units. Only then it is at equilibrium.
Yes.
But now I increase the temperature. Let's say the temperature was 500 Kelvin, and now I am increasing it to 600 Kelvin. What will happen? The endothermic rate of reaction will change drastically. For our example, let's say it goes to 20 units, but this increases only by 1 unit. Let's say it does increase 100%. It does increase, but only increases by a very small quantity compared to the increase in the rate of reaction of endothermic reaction. So what happens? What side does the equilibrium shift to?
Right side.
No, this increases, so yeah, right.
So here, can we write a conclusion that on increasing the temperature, although the rate of forward and backward reaction increases, but the equilibrium shifts to the side where the reaction is endothermic. What would happen if I decrease the temperature? The rate of reaction decreases for forward as well as backward reaction, but the equilibrium shifts to the side of exothermic reaction. पूरा sentence लिखना, ठीक है? Make sense? पक्का? Everybody with me? Okay. Now find one more way to disturb this equilibrium. Yes. Pressure. Because all of them are gases. If I increase the pressure, है ना? I am trying to make things compact. What would the equilibrium do? Try to decrease the pressure. I am increasing the pressure, the equilibrium will try to
Decrease the pressure.
make sense? Okay. This is gas. है ना? How many moles of this thing are there?
2.
And here 1 and 1. So there are 2 moles of reactants and 2 mole of
Product.
So here if I change the pressure, nothing will happen. Why? Because equilibrium is unable to decrease pressure. है ना? Nothing will happen. The position of equilibrium will not change. But let's look at another equation. Right? Let's say the equation was this. N2 plus 3H2 reversibly gives 2NH3. Now ये साइड पे कितने मोल्स हैं? 4. यहाँ पे क्या है?
2.
So in this reaction, if you increase the pressure, what will happen? The equilibrium will try to decrease the pressure. है ना? Now equilibrium cannot oppose you in this situation. So what will equilibrium do? Try to make molecules that occupy lesser space. So that will decrease the pressure. So on increasing the pressure, the equilibrium shifts to, and on decreasing the pressure, the equilibrium shifts to
Left.
Now what should be your statement here? As the pressure increases, the equilibrium shifts to the side with lesser number of gas moles. Lesser number of gas moles. And when pressure decreases, the equilibrium shifts to greater number of gas moles. एक एग्जांपल लेते हैं. Let's say H2O2 in presence of some catalyst, right, decomposes to H2O and O2, right? This reaction is taking place at 35 degrees Celsius, right? This is an actual question. कहीं पे ऐसा question है in your past papers, right? This reaction is taking place at 35 degrees Celsius. What will happen when you increase the pressure? If this is a reversible reaction, what will the equilibrium shift to when you increase the pressure?
To the left.
To the
Left.
because
Moles.
okay, let's say the equilibrium was like this: 5H2O2 plus H2O plus O2 plus some product X which balances the whole reaction. Okay? Then if you increase the pressure, what will happen?
You shift to the right.
But we don't know that H2 is a liquid.
चलो let's take this कि यहाँ पर whatever this thing is, right, the balancing part is 2, this is 1 and this is 1.
Okay.
Now if this is the situation,
And go to the right.
it will go to the
Right.
why?
Because there are moles, less
Lesser
moles.
of overall moles.
तुम्हारा आंसर सही था, you should have trusted yourself. ये रिएक्शन का टेम्परेचर क्या है?
35 degrees.
35 degrees.
So only oxygen is a gas over here, है ना? Are liquids compressible?
No.
So the change in pressure is ineffective in case of liquids. So if I increase pressure in this reaction, because only oxygen is liquid, the equilibrium will keep on shifting to left, no matter what is the mole ratio. So when we are thinking of pressure and we are trying to understand or trying to deduce that what will be the change in equilibrium in case of pressure, what you should look for? Only gases. Only, ठीक है? Make sense?
Yes, sir.
पक्का? हेलो, सुन रहे हैं ना? ओके, लिख लो यहाँ पे, लिखना होगा.
हमको calculate the number of moles.
ये इसका जो आगे का ये कोएफिशिएंट है ना,
Yes sir.
दैट इज द मोल्स। तो तू यहाँ पे अगर ये टोटल कर तो यहाँ पे 4 मोल्स है और ये 5 मोल्स है।
But sir, when you increase the pressure, it goes to the side with the lesser number of moles.
करेक्ट,
So then what?
but that affects only gases because liquids are not compressible. तो उन पे कितना भी प्रेशर बढ़ा, right? Let's say for example MnO4 reacts with Fe and produce MnO2 plus some other compound of iron. Okay? And let's say there are 8 water
Yeah.
taking part in this reaction.
Yeah.
ठीक है, इसमें कितना भी प्रेशर चेंज कर, इवन इफ दिस रिएक्शन वाज रिवर्सिबल, कोई फर्क नहीं पड़ेगा। क्यों? बिकॉज नॉट इवन वन कॉन्स्टिट्यूएंट इज गैस।
Makes sense.
ठीक है,
So in this reaction, only oxygen
Is
is
gas.
right? So we only focus on the number of moles of oxygen.
ऑक्सीजन
So here it has only 1 and there are 5.
1 and 0 बिकॉज यहाँ पे गैस कितना है, 0 मोल।
H2O2 is not a
Liquid.
gas. It's a liquid. Okay.
ठीक है, तो क्या होगा?
So if it increases, then it will shift to be that. If we only focus on oxygen, right?
We have to focus on oxygen because only oxygen is gas,
Gas. Okay.
right? And if when we change pressure, we only focus on gases,
Gases.
right? अच्छा, और कोई रास्ता है to disturb the equilibrium?
Concentration.
Concentration is equal to quantity, right? If I add a quantity of a reactant or product, that is equivalent to changing the concentration. So we know concentration, we know temperature, we have understood pressure.
Surface.
Surface area should again, if the product has a certain surface area, we can assume the reactant will also form in a similar manner, है ना? If I have powder of magnesium and I am reacting with oxygen, magnesium oxide will also be in powdered form. So that equilibrium takes care of itself, both sides same things are happening, है ना? Can you think of something else? What about catalyst? We know catalyst can change the rate of reaction, but can catalyst do something in case of equilibrium?
Sir, this one.
Can the catalyst support only one reaction, or should the catalyst support both the reactions? Both the reactions, right? So if I add a catalyst, the position of equilibrium does not change. Catalyst only helps in reaching the equilibrium faster, है ना? If I add a catalyst, the rate of forward and backward reaction, both of them increase by the same rate, and therefore the equilibrium does not shift, right? Catalyst cannot shift the equilibrium. Is this understandable? Pakka? Now let us look at one equation that is very very important in our syllabus. अभी तक मैंने equilibrium as a theory समझा है ना? हमको जो main पूछते हैं, that is what I am going to discuss now. There are two reversible reactions that are a part of our syllabus, बहुत ज़्यादा important. Okay, the first reaction is Haber process. N2 plus 3H2 reversibly gives 2NH3. Okay, 2NH3. As far as I remember, textbook में please check करो. This should be exothermic and this should be endothermic reaction. है किसी के पास textbook?
Yes sir.
Please check.
Yes.
It is.
It's the same.
The forward is exothermic. Is it correct? Perfect. चलो. Now, this reaction requires a temperature of 450 degrees Celsius, right? It requires a pressure of 200 kilopascal. It requires iron, and we take this iron in powdered form so as to increase the surface area of iron, right? Now in this reaction, this is a gas, this is a gas, and this is also a
Gas.
Pass.
ठीक है? First question, can you deduce why do you require such high temperature? 200 not kilopascal, I think 200 atmospheres of pressure is required. ठीक है, 1 atmosphere of pressure is actually equal to 10 to the power 5 pascal. So this is actually 20,000 kilopascal. If I convert this to kilopascal, it is 20,000 kilopascal. Right, somewhere. That is exactly what I was going to ask. Why do you use such high pressure? Looking at the equilibrium, can you guess why do you require such high pressure? Equilibrium का क्या? हाँ? The number of moles are less on the product side. So at a higher temperature, the equilibrium will shift to the right. So what is this process for? This process is for producing ammonia. Ammonia is the second largest produced chemical in the world because it is main product for main reactant for fertilizers. है ना? So fertilizers बनाने के लिए ammonia use होता है. Our target is to make as much ammonia as we can, and what we will do, we will try to make the equilibrium shift towards that will give us more products. है ना? Products is something we are doing this whole reaction for. ठीक है? तो why this high temperature, high pressure?
Because the number of moles and we need to shift the equilibrium.
Right? Now, what will happen if I decrease the pressure?
It will shift to the right.
है ना? It will shift towards left. And the yield of ammonia will decrease. What do we say? The yield, the amount of ammonia we get in the equilibrium state decreases. Make sense? Now, if the forward reaction is exothermic, why are we still using a temperature of 450 degrees Celsius? इतना ज़्यादा temperature क्यों use कर रहे होंगे? Can you guess?
To balance.
Balance what?
The equilibrium. If you're already using so much pressure to shift the equilibrium to the right, so to shift the equilibrium that we use.
अच्छा, okay. Without thinking all of these complex things, ऐसे simple सोचो कि what happens when you increase the temperature? So why do we use such a high temperature? To achieve a desirable rate of reaction. है ना? एक और bonus point है, which you cannot guess, कि iron as a catalyst gets activated only at such high temperatures. But the intuitive part is, at lower temperatures, the rate of reaction must be slow. And we need a certain rate of reaction, and therefore we use such high temperature. Why do we use iron? It is a catalyst. It does not play any role in equilibrium. है ना? Now, in this process, देखो, अभी तक we have understood everything theoretically, right? Now, why is ammonia produced? And this must be a costly process, right? It is happening industrially, है ना?
Is it expensive than electrolysis?
Should be expensive than electrolysis because extraction of hydrogen,
Is hard.
right? Hydrogen comes from fossil fuels. Cracking of fossil fuels gives you hydrogen. Nitrogen मिलेगा fractional distillation of liquid air, right? Both the processes are costly. And ammonia is in such a high demand that it will be costly, ammonia itself. है ना? So, I want a very good rate of forward reaction, right? So what I will do, I will do everything in my power to produce as much ammonia as possible. What I will do a little bit of cheating. क्या करेंगे? Instead of producing this in gas, we will condense this to liquid. As soon as this is liquid at such a high pressure, the equilibrium stays towards the right. है ना? We will do one more cheating. We will continuously keep on extracting this liquid ammonia as well. So the equilibrium never actually establishes itself. It keeps on producing more and more. But this is important because I want to keep on adding more nitrogen and hydrogen. है ना? I will keep on adding more nitrogen and hydrogen. This will keep on producing ammonia. I will keep on extracting this ammonia. And the equilibrium always remains towards the product side. Even if I am adding more of the reactants. Make sense?
Yeah.
Akka? Okay. Now in the next class on Saturday, we will see more of this. Okay?
Thank you.
Like actually